When a nation wants to tell the world it's on top, it builds monumental, magnificent, and masculine. But in China, a new silhouette is rising over Guangzhou city. The Guangzhou TV Tower. It's nicknamed the Supermodel.
It looks more feminine. It reminds a little bit of a dress of a woman.
The tallest TV tower on Earth with a super slim waist. Some called it a blueprint for disaster.
Some experts argue, say it's dangerous. They will collapse.
But others have the courage to see it through.
It was like now or never, so we just had to go for it.
In construction-crazy China, thousands of welders go to work every day. These welders have a uniquely risky job. Just getting to work is an uphill struggle. Their job site. A dizzying 450 meters above ground. That's when their real job begins. Welding on top of the world brings a whole new set of challenges that steel supervisor Mr. Guangzhou is only too familiar with.
Among all the projects I've worked on, the tower's steel structure is the most complex and difficult. We need to protect the welding joints from wind and rain.
What they're constructing is no ordinary building. The Guangzhou TV Tower. When it's finished, it will be the world's tallest TV tower and one of the tallest buildings in China. But it isn't the extraordinary height that keeps the construction team awake at night. Its design is like no other. It has a concrete core that rises to 450 meters. The core is enclosed by a giant steel lattice formed by 24 steel columns and 46 rings. The tower twists midway to form a waist, then widens in an oval at the top. The crowning glory is the TV tower's spectacular antenna, rising another 156 meters, taking the tower to 610 meters, the tallest of its kind on Earth. Its shape is so unique, it isn't covered by any conventional building code. They're boldly going where no builders have ever gone before. But that didn't stop architect Mark Hemmel, project manager Vincent Lam, and engineer Jackie Yao from taking up this crazy challenge just 4 years ago.
I can still remember that sort of sketches that the architect handed to me. When I start to thought, wow, it's nice cartoons. And then how we are going to work on it.
There's a way to make an entrance.
This is my destiny.
It was now a conspiracy of witches.
Download Veely
today.
You're doing a project that that is of a scale, of a size, and of a complexity that nobody else has done before.
One day, a crazy architect, he make a dream. The engineer is trying to make that dream to be realistic.
4 years on, and they're turning Mark's dream into concrete and steel.
I think it's very nice like this, the fact that it's quite an open structure now, so you have a view still through over the whole city.
For the last 3 years, architect Mark Hemmel has commuted regularly between his home in Amsterdam and the construction site in Guangzhou. He's just one half of IBA, the architectural firm that conceived this design. The other half is Barbara Koot, Mark's partner in work and in life. They'd only been in business for 5 years when they decided to take on the big boys, competing for the job of a lifetime by designing the tallest TV tower in the world.
I first heard about the competition, and then I read and I heard that there was required a high tower in China, and my first thought was, well, that's quite big.
And she said, well, what do you think? It's nothing, isn't it? Like it's too big, too difficult. And I thought, like, no, we should do it.
The winning design would have to make a powerful statement to the world. Situated in the southeastern province of Guangdong, Guangzhou is the 3rd largest city in China, and it's the center of Chinese manufacturing. A 1,000 years ago, the port of Guangzhou sat on the trade route that linked East Asia with the Mediterranean. This was one of the first places in China where East met West. Today, Guangzhou has the economic might of a modern megacity, but has yet to reclaim its former glory. But that's about to change. 2004. The city wins the right to host the next Asian Games and takes on the mega challenge of a citywide makeover that must be completed before the Games begin in 2010. The jewel of that mega makeover will be an iconic high-rise, a 21st century communications beacon. The Guangzhou TV Tower. 2 years out from the Games, the outer structure is almost complete. The steel lattice has reached the topmost ring. Only 3 more column sections need lifting into place. Each section is 11 meters long and weighs 25 tons, like lifting 10 full-size pickup trucks. This is one of the last of the 1,104 column sections that make up the 24 giant columns. Positioning those columns is the most critical part of this job. Each column must be aligned correctly. Inside the column, worker Liu Chao fastens the brackets into place. There's no room for error. Even a few millimeters off, and the whole tower could morph out of shape. Below, a team of surveyors guides the workers to ensure the section is precisely positioned.
Burn inside. Burn it right now.
Then the smoky part of Liu Qiao's day begins as he welds the two sections together.
When I first went inside a column, I was a bit scared, but after a while, I've got used to it.
With the welding complete, Liu Qiao makes his escape. Ten floors below, workers are assembling the steel floor. Because of the twist in the middle of this tower, every floor has different dimensions, so every floor beam and floor plate has been custom made. They work so efficiently, they finish one floor every 5 days. Five years ago, when the architects were competing for this job, the odds were stacked against a small firm like Mark & Barbara's. But that just drives them harder. They decide to give their design a twist.
This is a very simple idea. You have the top and the bottom rotated. Therefore, you got the effect was that you get like a tightening waist. And we like the form so much because it kind of reminds a little bit of, of kind of it looks more feminine. It reminds a little bit of a dress of a woman.
But their clever design poses huge technical challenges. To land the job, they need the prestige of a big engineering firm behind them. A friend introduces them to engineer Joop Paul, who works in Amsterdam for Arup, one of the biggest engineering companies in the world.
It's like if you're not big, then you have to be clever. So we immediately asked as much help as we could.
When I saw the model, I thought, wow, this is really cool. Yeah, this could be a real winner.
But for this competition, it isn't just the technical details they have to master. They need to engage a Chinese audience to make something that will win over the people of Guangzhou. Mark hires Patty Liu as translator and cultural advisor. Tapping into the Chinese love of storytelling, she suggests writing a modern legend inspired by the tower itself.
I suggested to Mark that I would write his beautiful architecture into the legend about a beautiful lady standing alongside the river, looking proudly and hopefully into the Pearl River and look far beyond the future of Guangzhou.
Armed with the legend of the Lady of the River, the team works day and night. It's especially hard on Barbara, who is pregnant with her second child.
When I'm focused, I'm not worried about anything else. I was just focused on the tower, focused on that we had this amazing chance and that we should go for it.
Zhu Yuyong gets high every day he comes to work. He climbs a 50-meter ladder, an exhausting 15-minute journey, to the cab of the Favel Favco M900D tower crane. He's been at it for 2 years now. One of 8 drivers he took special training to drive the crane. After decades of working with ordinary cranes, he's reached Cloud 9.
It was my first time to climb so high and on a crane so good. I was really proud. It's an Australian crane. And Australia is a great country, right?
By the time the tower is completed, the cranes will have lifted 650,000 tons of steel. Enough to make 65 Eiffel Towers. This mega machine can lift 64 tons, making this 1-ton floor beam a mere toothpick. It can take it all the way to the top in just 15 minutes.
Normally before I go to work in the morning, I don't dare drink much. Why? I'm afraid I'll need to pee.
Guangzhou hasn't always been this high. This crane can grow along with the tower. Powerful hydraulic jacks have pushed the 280-ton crane skyward, 4 floors at a time. As the concrete core grows at the brisk rate of 1 floor every 5 days, the crane grows too, with new tower sections inserted as the construction moves ever higher. Guangzhou is now working 500 meters up. But height doesn't faze this crane-driving veteran.
The higher the workplace, the fresher the air. In contrast, working on the construction site on the ground could be annoying.
He certainly has a room with a view. And when complete, this tower will offer the best vistas of Guangzhou city and become an attraction in its own right. 2004, and world-famous firms are competing for the contract to build Guangzhou's new icon. As the finalists are chosen, Mark and Barbara have even bigger things on their minds.
The day that our second daughter was born, she was just there for a couple of hours, and Mark's telephone rang, and then we heard that we were one of the 3 that final schemes that were chosen, and that there was a lot more questions that the client had that we had to answer straight away.
The timing couldn't be worse. A new baby in their arms and their dream project just out of reach. They have only 3 weeks to draft another round of plans and drawings, or lose everything they've strived for to the other finalists. Time isn't their only enemy. Mark and Barbara have sunk all their savings into winning this prize. For this young family, failure could spell ruin.
We had to sort of use all our available funds, and at some point they ran out, so we had to knock on many doors for help.
Job Paul, their engineering partner at Arup, recognizes just what a risk they're taking.
They took a huge gamble. We normally enter, we win a lot, but we also lose. If you just have one bet and you place all your money on one bet, it's very risky.
On floor 75, they're about to start laying more floor panels. But nature throws a wrench in the works. Steel supervisor Mr. Wang must decide if it's too windy to risk laying steel at this height.
Is it safe? Do you have your safety staff coming? This hole is in the middle of the air. A small panel could easily be blown away by the wind. The wind might even drag the worker with it. It could be very dangerous.
Wind is no stranger, but a familiar foe. Guangzhou lies squarely in the path of southern China's annual series of typhoons. Around 4 tropical storms sweep through here every year. In September 2008, Typhoon Hagupit hits the southern tip of Guangdong province. It drives 28,000 from their homes and destroys more than 18,000 houses. As the tail end of Hagupit blows through Guangzhou, engineers halt construction. If a superstorm ever hit the heart of Guangzhou city, how would this slender reed withstand such a force of nature? The engineers reach out to scientists. Professor Julia Dong of Tongji University in Shanghai is in charge of testing how the tower would fare under extreme winds. The tests are more complex than for any normal high-rise.
It's a unique asymmetrical shape, so it has an extremely complex wind environment.
Using a perfect model of the tower, they test wind pressure at different heights and wind speeds up to 160 kilometers per hour, a scale 14 hurricane. The results reveal the most vulnerable part of the building is the antenna. It will need strengthening. Their verdict? The tower should stand up to nature's worst winds.
I think the current building is safe enough. Even if we have a once-in-a-100-years typhoon, the building can stand up to it.
After biting their nails for 6 months, Mark and Barbara finally learn they've won the design for the Guangzhou TV tower. Arup in the Netherlands joins forces with the Arup officers in Shenzhen and Hong Kong. And the team that must breathe life into blueprints is born. Everyone agrees the tower's thin waist clinched the competition. Now they must decide just how thin they can go without blowing the budget.
The thinner you make the waist, the weaker the building becomes.
Every meter they narrow the design will add 2,000 to 4,000 tons of steel reinforcing. They have to pin down the basic stats, the supermodel's dimensions. They generate a computerized model that lets them build virtual towers. They experiment with the number of rings, the number of columns, and the size of the waist. They discover that reducing the number of columns from 36 to 24 gives the supermodel the perfect dimensions. But the next problem is even more complex and costly. The tower is held together by joint connections or nodes. They take a whole lot of steel, and in Mark's design, every one of them is different.
So that meant that all the joints would have been different. It would be about 2,000 joints, and they would be all totally different. And, well, that would be very pricey.
Their solution: standardize the shape of the joint connection. Though each node is still one of a kind, they'll be easier to mass produce.
It's almost mass customization. Yeah?
To top it all off, the client adds a challenge: a revolving restaurant.
We have an elliptical concept, basically, an elliptical building, so it is impossible to make that rotate.
Their solution: design a circular restaurant that rotates around the concrete core. Then they must work out how to fit this circular element within the elliptical outer structure.
Means that you do the same work over and over and over, and sometimes you have the feeling that there is no end to it.
Finally, both the architects and engineers agree they have a tower that can be built. But convincing the Guangzhou construction company is a different story. Arup takes the unusual step of commissioning a computer animation to prove this unique design can actually be built. In 2005, the city of Guangzhou welcomes the designers of its towering icon. In November, they lay the cornerstone, and the Guangzhou TV tower is on its way. 3 factories begin the colossal task of outputting the steel. Steel is the backbone of this hybrid building. 650,000 tons of it will be precisely shaped into every element that makes up the mega tower. Technicians extensively test the steel to measure how it stretches, bends, and withstands force. To save time and labor on the construction site, most of the welding is done at the factory. They test every weld for defects using ultrasound. Every element is pre-assembled to exacting specifications, because on site, everything must fit together seamlessly. August 2006. As the manufacturing continues, the first column goes in. 2 years later, they're reaching the upper heights of construction. After they complete each ring, they fill the columns with concrete. Concrete-filled columns are almost as strong as solid steel, but cost much less. Now the construction crew begins to concrete all of the tower's 88 floors. Concrete, one of the oldest construction materials and still one of the trickiest to handle. Incredibly heavy, and like a ticking time bomb, there's only so many hours before it sets. But no problem for this machine. This concrete pump is state-of-the-art. It can pump concrete to the top of the tower at 30 meters per second. That's nearly 110 kilometers an hour. The main pipe carries the concrete all the way to the top and has openings on every floor. On the 77th floor, they're ready to roll. They start with their longest boom, so they can reach the places farthest from the core. This concrete is especially designed for pumping into high-rise structures. It's called self-compacting concrete, or SCC. It flows and spreads easily and settles into place by means of its own weight. It's ideal for penetrating small spaces. It also penetrates the workers' clothing. Concrete spreader Xi Bingfa knows the true meaning of concrete gumboots.
These clothes can't be cleaned. I'll just rinse them a bit and then wear them again.
From the laying of the foundations to the finishing of floors, Mark is never far from the action. He visits Guangzhou once a month to monitor progress.
It basically feels a little bit like as if it is our baby, and therefore we have to care for it and we see it grow up.
Back in Amsterdam, Barbara looks after the office and the family. She provides timely backup for Mark when he's on site. At the end of Mark's day, he can ask the Amsterdam team to turn around plans during the night, so they're ready for him in the morning. For Mark and Barbara, the space outdoors matters as much as the space indoors.
The building is basically an outer structure in which 5 buildings have been hung. We're now standing on top of one of those buildings, and this is going to be a garden which doubles up as a refuge floor in case of emergency. From here also the skywalk will start.
The skywalk is an outdoor spiral staircase that goes from 168 meters to 334 meters, allowing intrepid visitors to climb through the narrow waist of the building. The journey up through the tower is designed to be an experience in itself.
We didn't want the tower to be something that you would see in 5 minutes and go to the top and you couldn't remember how you actually got there. So we wanted people to be able to take the time and see lots of aspects of it.
The waist is the one area where the core and the lattice aren't connected to each other. So to give the tower extra stability, they've added web bracing every 40 meters. All are pin and expansion joints, which allow for movement in the steel caused by sunlight and wind. Down below, the Favel Favco M440D crane delivers another shipment of skywalk pieces. Then an even larger Favco takes over. The M900D delivers them into the body of the tower. It's a long and precarious process as they hoist each piece of skywalk to the work platform. Inside the tower, avoiding collisions with the web bracing is like threading a needle. Above them on floor 80, Mark checks out the emerging skeleton of the revolving restaurant. A restaurant 400 meters high poses challenges not just for the designer, but also for the chef. In stormy weather, the tower might sway as much as 1.5 meters each way.
It means that you cannot design anything that would give people visual clues about that they're actually moving, because that is one of the reasons why people feel sick, because they see things kind of unusual that they're not used to. So for instance, you could not have any chandeliers in the restaurant because they would just sway above your table. Same thing works also for a chef. He has to take into account that he cannot serve a plate with soup, because the soup would just disappear out of your plate while you're trying to eat it.
But queasy diners are a minor problem compared to what's weighing on everyone. How the slender tower will stand up to a real upset. Memories of the 2008 Sichuan earthquake are still raw. Although Guangzhou is not in an earthquake hotspot, experts predict it might suffer a level 6 quake in the next 2 decades. At Guangzhou University, earthquake expert Zhou Fulin runs tests to ensure the supermodel will withstand nature's wrath. More than the occupants' lives are at stake. In an emergency, the tower itself will broadcast messages to millions. Working for almost 3 months, Zhou's team builds a scale model over 12 meters tall, 1/50th the size of the tower. They subject the model to an earthquake with a seismic intensity of 7.8. They find weaknesses in the antenna and the waist, but nothing that would jeopardize its structural integrity.
So the earthquake problem, I can say, no problem. If very strong earthquake, with double earthquake, no problem.
To stabilize the weak points and reduce swaying, the scientists recommend a big addition: dampers. Tuned mass dampers, or TMDs, feature in many ultra-tall buildings. They're often giant concrete blocks or steel pendulums that move in the opposite direction to minimize the whiplash caused by winds or quakes. TMDs are costly and take up lots of room. But engineers have come up with a unique solution that saves money and space. 2 giant water tanks, 600 tons each, that double as reserve tanks in case of fire. Housed above the restaurant on floors 84 and 85, the tanks sit on rollers, so if the tower starts to sway one way, they'll move the other. Above, in the antenna, are 2 smaller mass dampers, each with a 2-ton steel counterweight that also counteracts whiplash by swinging in the opposite direction.
If the building moves there, and this mass will again, so can reduce its vibration.
Together, the dampers will reduce vibrations from wind or earthquake by up to 50%. These dampers are linked to a computerized building health monitoring system, a new model for high-rise construction worldwide. As construction proceeds, more than 600 sensors testing everything from vibration to temperature are embedded in the steel columns and the concrete core. The sensors make this the most scrutinized high-rise in the world. They'll not only safeguard this tower, but furnish valuable data for building the super towers of tomorrow. Safeguarding the structure also means protecting the lattice against corrosion. It's a top priority for steel supervisor Mr. Wang Shua.
The paint job for the steel lattice on the Guangzhou TV tower has some strict requirements. It's more or less similar to a paint job in the shipbuilding industry.
Most of the painting has been done at the factory, but every joint on the steel lattice must be finished on-site. First, each weld is sandblasted to remove any rust. Next, a protective coating of aluminium, the same kind used on bridges. Then 3 coats of paint go on every joint. Shifting to the next column at 450 meters above ground takes nerves of steel. One decision remains up in the air: the final color. By sunset, workers are installing one of the last sections of the topmost ring. The outer lattice that some said could not be built is almost complete. The day shift can relax. But this evening, work goes on. High winds have set back construction. Evenings are calmer, and the night shift races to catch up. Designing windows for a building with a twist posed an unusual challenge.
Because of the fact that the building is so curved, the upper line of the window line is different from the bottom one. So you could never fix it with straight rectangular windows. So basically the only way of doing it is using triangles, and they can kind of follow any form.
Although no 2 pieces are exactly the same, every window is roughly 3 meters high and weighs nearly a ton. It takes 6 men to maneuver them into place. Cut to precise specs at the factory, the windows slot together like a giant set of shark's teeth. By the time the tower is complete, the window team will have done this job 5,000 times. Throughout construction, the only way up and down the tower is in the makeshift lifts. They move everything that can't be hoisted by crane. William Wong and his team from Arup, Hong Kong have the challenge of designing the regular lifts for such a slender tower.
There will be a lot of tourists coming to the tower, 10,000 a day maybe. So the lift vertical transportation requirement is very high. But at the same time, because the core is very thin, so we have to think about how to stick this so many lifts into such a thin core.
The answer is double-decker lifts. They can carry twice as many people in the same floor area. When the tower opens in 2010, 2 double-decker high-speed lifts will whisk visitors straight to the top in just over a minute. A second set of double-deckers will provide a more leisurely journey. They'll give visitors a strong sense of the building's height and unique structure.
And that is kind of what I found missing in some other buildings. Often they use the fastest lifts, while actually the slowest lift will give you much more of an intuitive feel of the height of the building.
But the lifts are far more than simply passenger transportation.
After the 911, people were concerned in case of accidents or fire. How are we going to evacuate people from such different height levels back to the ground level?
Research post 9/11 suggests using both the lifts and the stairs in an emergency can almost halve the time needed to evacuate a superstructure. In the Guangzhou TV tower, visitors can use the fire-protected stairways to escape the building.
We decided to go for 2 hours, so the people have 2 hours being protected before the structure or the fire reach them in the staircases.
But those fortunate enough to access the lifts have a faster escape route. Computer simulations show the high-speed double-decker lifts can ferry 840 people from the top of the tower to the ground in just 1 hour. The first tourist has yet to step inside. But already painting begins on the concrete core, and the outer lattice is nearly complete. Finally, the end is in sight. For Mark Hemmel and Barbara Coote, designing the Guangzhou TV tower has changed their lives.
I think it is a once-in-a-lifetime opportunity. You don't get such a chance. You can't dream of that you would ever have a chance like this to be able to make such a building that will probably play an important role for the city, or maybe even for a whole of China.
I would do it again because I'm just I'm not afraid to go into the deep, if you like. So I would do it again, but I would be frightened. But I would do it again. Yes.
When the Guangzhou TV tower is finally complete, it will not only be the world's tallest TV tower, it will boast the world's highest Ferris wheel. And when the Asian Games open in 2010, the supermodel will be the icon that puts Guangzhou City center stage.